I'm Jonathan. Welcome to the Business of Software. Today we're going to be talking about designing for the future. And really this has come about from the move that we've taken. 30 years ago, big design up front. We're now in an agile world. What are we doing for design? How are we preparing our software for next week or next month or next year? And really this is at odds a little bit with 50% of the industry, if I can come up with a number, where some are still continuing on having some kind of design, doing something up front, a little bit of understanding of what's going on, a little bit of architecture, known architecture, and then building some stuff. And a lot of people experimenting or doing the other approach, which is a kind of an emergent, do small units, test these units, and eventually we will evolve into some kind of architecture. This is a fundamental problem because that's not how architecture exists. Architecture is not necessarily the sum of the parts. Looking at it from a holistic point of view, from a top-down point of view, we don't want to go to pseudocode either. We don't want to build systems up front in an elaborate way only to find that we have done it wrong. Is there something in between? Have we, perhaps this isn't the real dichotomy, but it does feel that way. It does feel like every day in a team we are building things with a faster reactive point of view. We are looking at green, red refactor. We are looking at, we'll refactor later. Tech debt is something we can delay. We don't have to do that now. We are fostering a speed. Let's do a sprint culture. We are fostering a quick, continuous pipeline, a continuous deployment. How quick can we go sort of mentality. And this isn't how you build large, robust, and awesome systems, in my opinion. I think that you have to have a little bit of both of the worlds. How do you fit these together? Now, a lot of you out there might be doing this instinctively. There's a lot of good software out there, so therefore there must be an element of getting this right. People who are thinking ahead a little bit, designing something, refactoring and remodeling and redesigning and redoing as they go, but yet there is a vision. There are obviously people out there and teams out there doing this. For those that aren't, for those that think that any form of design up front is kind of bad, for those who think that any form of design is big design up front, we're going to push it that way, this is where it is. And for those who think that everything has to be shifted left in the sense that we have to test first and we have to work with micro units and we've got to do things like that, who don't quite understand the holistic picture, I am developing a set of guidelines, heuristics, things to consider, just to throw out there and say, look, are you thinking about this? Are you thinking about that? Perhaps you are. That's wonderful. What's the trade-off between this and that? Are we thinking of trade-offs correctly? And so on. So I'm just a thinker, and this is the result of thoughts. So what I want to do is just take you through a very short sort of reflection of the last thoughts that I've been having over the last sort of month or two. So really designing for the future is something that I think we can achieve. We can look ahead. We can build something that does not need to be changed. That's a large statement. I guess that is. There is a caveat to all this. When I say will not be changed, there is obviously a timeline. Things do change, we know that, and we'll discuss that in a minute. But when does it change? That's a more interesting question. What are we saying in 2021? Well, we're saying that requirements change. We're saying that we need to ask the customer. We need to continuously deliver some form of value. We're saying that shorter cycles are better. We're saying that TDD is better. We're saying that we must have principles and software, that we must use the cloud to our advantage. Great many of us are using Scrum and coaches. Coaches have now I don't know when it was born. I don't know much about it. It seems a bit odd to me, but there are coaches everywhere. This is what we're saying in 2021. And the real question here that I have to all of these is, requirements change, fair enough. What type of requirement changes more often than another type? That would be a question, right? How often is change, right? What is that rate? Is it weekly? Does it need to be weekly? Is it monthly? Is it yearly? Are we designing things around this change, and the change is only, quarterly, but yet we're putting all this micro effort in? We have to balance when change occurs and why we're doing change, and understand these questions a little bit more deeply. Now, I want to paint more of a picture of what's happening right now. And I thought the easiest way to do this is to show the protagonist and the antagonist. And really, I've only chosen 3 roles. So we've got the fast, testing, customer-centric, daily communicating, value-driven, refactoring, cloud-certified coder. Right? This is the type of coder that business seems to want now. We are involved in daily stand-ups. We have to be good communicators. We have to write things down. We've got to talk about, we've got to stand up and say what we did yesterday. We've got to have retrospectives. We have to think about customers. We have user stories. We have everything geared to make us one of these. The manager is a card-checking, velocity-seeking, value-driven, continuous delivery, buzz-talking, agile, certified manager. There's a lot of that. You can't find a role that doesn't say something about some kind of certification, which is largely, in my opinion, made up, inverted commas. Made up? Yeah, everything's made up. How long have those things been in existence for? How good are they? How scientific is the approach? That's up for debate. But that doesn't stop us from wanting those certifications without a doubt. The third is that we're doing all these things because we have a support querying, requirements asking, high spending, value wanting, continuous app updating customer. We think of the customer as wanting change, needing an update. They can't live without it. They're going to move. They're going to go somewhere else if we can't meet their requirements as quickly as possible. As a business, we must be agile, so we have an agile coder, an agile manager for an agile customer. The antagonists in this world, well, that's the deep thinking, design-oriented, future-proofing, always questioning, low communicating coder. Perhaps the macro manager, and the knows quality and simply abandons the app for something better customer, right? So we sort of neglect those customers that they come in, or the idea that a customer might download an app and within minutes decide, don't want it, deletes it and moves on. They're not with us in the long haul, and they're our antagonists, really. We want value-driven things for value-wanting people. This is the state of 2021. So what is this kind of idea doing? Well, what it's doing is facilitating a reactive environment. We are reacting to something that somebody wrote down on behalf of a customer, right? This is the story. User went to the dashboard. He couldn't see in an easy way. He couldn't see a statistic that he needs to make a decision. We've got all this real estate. Let's do something about the statistics. The statistics that he wants range from this, and that. Let's see what we can do here. I'm building a very strange and possibly horrible story, but there you go. We've got something like that. And we take that idea, and the developer is supposed to take that as a card and do it. And do it. Just go in and just do it. And so now it depends on their approach, really. How do they think, and what is the team culture? So in one type of culture, he goes in and he writes some code and he checks it out and commits it, and a tester perhaps looks at it. In another culture, he's doing the test, and in another culture, he's writing a unit test after. In another culture, he's designing something and showing it to someone who approves it and then writes the code. We have all these different methods. But anything that has a stop, something, a block, something that we can consider a block, is going to be thrown out. So if we're going to send it to an architect, and an architect is going to design something in UML and send it off to, I don't know, the enterprise architecture team, and they're going to approve something, and then it's been bouncing back and forth and go to a team lead, and the team lead is going to tell you about what their ideas are, interpretation are, and there's a couple of meetings in the way of this. You can bet your life that most of that will be thrown out at some point. And it depends on the organization and the size of the organization. But in today's mentality, we want to remove waste. So therefore, a lot of that is considered waste. Can the developer be more efficient? Can they be more accountable? Can they build a test outlining the story, develop the software, and it's automatically marked? Can I see it in my app, my Jira? Can I see, oh, there it is, it's done? Can I have faith that that is done, and how automated can I make this? So everything at the moment is really trying to squeeze life out or waste out of a process. We are geared to be faster, we are geared to think faster, we are geared to, if you can't think fast with a lot of things, think fast with a little thing. Get that little thing in. Do a micro commit. Let's integrate now. Don't wait. Let's deploy it today. Let's get that feature to the customer and get feedback on that customer immediately. This is 2021. It's a very reactive way of doing things because we are reacting to a story, we are reacting to a customer's feedback, we are reacting to the change, as in a test or a breaking test. We are reacting to things that we put in the way or that come our way, and we're reacting to it. Often what happens in this kind of environment is, I call it firefighting, many of us do. You get to a kind of position where the bugs that come in, the feedback that comes in, is a little bit too long than the time you have to build the things, so therefore you get a slowdown. But that's the nature of trying to go faster. And you can write your comments below in the YouTube video about this, but not everyone's going to agree, but I do feel there's a kind of self-fulfilling prophecy in this. We are trying to deal with change. We think change is important. We think our business must respond to change. We are change obsessed, and in doing so, we create more change. We're creating deployment pipelines. We're creating automation and feedback loops that come back at us far quicker than we can react sometimes, or at least quicker than we can react successfully. We can react without mistakes. And when that occurs, if we do make a mistake, we get a lot of reaction again. A lot of feedback comes back. And so we're expected to write our tests and be better and do that test first and do a couple of tests and do third and fourth tests and make sure and do system integration tests. And we're all trying to solve this problem that we are creating by going too fast. One could argue that a few developers in a room who are pushed and driven compared to another, which are, they have freedom to adapt and design, that they would be late and take long, and these guys would be very fast, and that's better. Or you could look at it as these guys are designing something that has longevity, and these guys are throwing a lot of things away in favor of new things, treading water. Depends how you look at that. This is my opinion on this. I think we are becoming a very, very reactive team. So as I said, the irony of being reactive really is that we are in taking away certain checks and balances, or certain roadblocks in a process by pushing and going too quickly. We are creating mistakes and we are causing more change. Now, the opposite of reactive is proactive, but I don't want to look at its positives quite yet, but let's look at its cons first, right? If you are proactive and you do quite a lot of stuff up front and you're wrong, you're basically creating a reactive scenario. You're fueling reactive. You have to make change now. You have to change it. You have to, and sometimes it can be quite hard if you've been proactive for a very long time without feedback. But that doesn't necessarily mean that, proactive doesn't mean that you don't get feedback. You can proactively go and get feedback. What does proactive mean? It means kind of deciding what to do ahead of time, trying to prove that it's the correct way to do it before it's actually required, and somehow being ahead of the curve, somehow knowing and understanding that something might happen or will come about, so therefore I'm going to do it now. The negative, of course, is you do too much. You over-engineer, and that causes some reactive behavior. You also get some other things, like everyone knows you were wrong. You said that this is the right thing to do, and you're wrong. And that has its own psychological connotations, especially in a team. You can be proactive in the wrong direction, right? You can go off in the wrong direction, and it depends how far ahead you are. If you're a couple of years in the wrong direction, that could be serious. If you're a couple of weeks in the wrong direction, perhaps not, right? Because the reactive world is dealing with change anyhow, and we're redesigning and refactoring and doing all that stuff anyway. We have those kind of tools, so perhaps if we were a bit more proactive and we were wrong, it wouldn't be as big a deal as it used to be. Now, I just want to address something that has bugged me for a long time, and that's the sort of mixed messages that you receive. It's an agile world, but we've got XP, extreme programming. Now, test first, it does slow you down. I mean, you can argue that, yeah, it speeds me up if I've got 100% coverage, and, fair enough. Get started with a program. Have 4 top developers here and there, one doing TDD, one not, and the one will pull away faster than the other. That's for sure. The trick about TDT, or what is said about TDD, is that eventually that will make you faster. So that at the end, while the other team is now dealing with issues and don't have anything to contain and constrain their refactorings and highlight where problems might be, you pull ahead even faster. That's the idea. However, it's probably only really the top level of TDDers. And everyone likes to think that they're the top, just like all drivers think they're the best drivers. But really, there has to be a pyramid of those better than others. And if you go by any standard of any curve that you might imagine, Dunning-Kruger effect or any of those, you will imagine that it's probably the case that the majority have a far less understanding of what they're doing and a far less level of quality than they think. And I think for the most part, this creates more problems for them. If a practice relies on you being the very best at it in order to do well with it, that's okay. I mean, that's probably everything. Coding is the same. But then it becomes not about the same sort of rules then. It becomes, okay, so you have to prove that it provides overall benefit, right? You have to prove that at the end you are faster. It might be entirely counterintuitive and it's entirely right, but studies have revealed that it's about the same in most cases. how long does it take to get to a test first sort of scenario on an existing project? Like if you've got legacy code and you have to do all those tests and start, how much faster does it make you? You have to change the test as well. So you do a change, well, you have to change the test sometimes. Sometimes you don't. It's a pure refactor. The word refactor and redesign is often interchangeable with some people. Daily stand-up slows you down. Let's just think of that. So one could argue, oh, it speeds you up because you learned something you didn't have to do. Yeah, but I could have done that if I was a good communicator and popped off an email that took 2 minutes rather than 10 minutes. Daily stand-up clearly slows you down. I've been in teams where we've done the daily stand-up. It always goes over, 5 minutes, 10 minutes, sometimes an hour, depending on what's going on. Right? Yeah, there are dysfunctional teams, situations. In those cases, daily stand-up during that week is going to slow you down. You're going to get 2 to 8 hours per week less actual work. And there's kind of like this mixed messaging. You need to run, you need to sprint, but hold it, let's talk about this. Well, if we're going to talk about something, well, why can't we throw something else in? Like, let's think about it, right? I'll get back to you. I mean, maybe that's not such a bad idea either. The way I look at designing for the future is that you kind of want a balance between the domain knowledge and the technical knowledge that you're throwing in on that project. And there's this sweet line. There's this line that runs this way. And this is your sweet spot. This is the trajectory, the correct trajectory, whatever that might be. And this is where you want to be. This green circle represents perfection. You're on the line. That means you have architecture and technical capabilities in the application that's Goldilocks. It's just right. And if you're under engineer, well, your business wants a type of capability that your technical just cannot present in a fast enough way. So what we're doing is we are under engineering and being reactive, trying to build up to this line week by week, iteration by iteration. This is what we're trying to do. We're trying to under-engineer and just in time bring things in to bring it closer to the line. And where I find that scary is that in all the code bases I've seen that follow this agile / TDDs, it's not one thing. There are people doing it correctly, there are people who are doing more correctly than others and so on, but there is an overwhelming weight, a force, a push for under-engineering. And in doing so, there's a kind of a catch-up. And you can never quite get the kind of design level that you need when you spend time on it, real time on it, and versus that kind of pressure firefighting environment. What tends to happen is by the time your tests start really helping with regression, but really helping with redesign and all of that kind of stuff, you've got this extra weight that you need to get the design up to a suitable engineered. You'll see that line is going up for a reason. Everything goes up. Complexity increases, entropy increases. That line is at a gradient. And you might start and everything's hunky-dory at this point, but it's going to get more complicated like any other code that we do. Okay, so if you can't see this line, my take on it is that we need at least to understand in what direction the dotted line should be. Dotted line is not sure. It's not in stone. It's not a hard, solid line. But it does say like in what direction we're going. And we have a vision of the future and we have a direction. So when people say, well, we under-engineer because, we can't design up front, we can't design anything really because, things change. Everything changes, right? Death and taxes, that sort of thing. Well, the problem that I have with that is that it's a very surface level one way of thinking. Everything is going to change at a different rate. Your disk space is going to fill up differently to another team because they've got a bigger hard drive. Programming languages are going to change less frequently than perhaps organizational process. I put organizational process here. Look, it's in fast. Maybe you don't get to change organizational processes that quickly. Maybe it's over here on the slow side. And that brings context. That means that your context is different to mine. Your context, your organization, your culture, your rates of change for all these kinds of things are going to be subtly different or vastly different. We don't know. So everything here is going to change at an entirely different rate. If you're in a greenfield project, you're right at the very beginning. You're doing your tests, you're doing some code, you're doing some design, things feeling great. And I say, could you please change a few table names and a couple of field names? Can you do that? And you say, no problem. 4 years in, no matter what system and method you have, it's going to take time to implement. The rate of change affects whether we are going to be likely to do it, but the change gradient, the what I call the change gradient, is going to change the longer you put it off. So if you're beginning of a project, the change gradient is 0, and as time goes by, that will increase. It's a number between 0 and 1. Complexity is also something that increases continuously over time. Complexity comes from the fact, if we just simplify our code, it comes from just the nodes and edges, all the relationships that we have between this and that. That's what it builds. It's building a network. It's building a system. And that system has coupling. It has connections, and in the connections of connections, it becomes complicated. There is nothing you can do about it. So we have a principle called decoupling, right? We've got coupling, we need to decouple. Well, if you do that, you've got a set of things. You've got cups on the table, they are a set of cups, they have no relationship. I can replace the cup with another cup, no problem. But in a system where things are connected, you have a different sort of scenario, different thing that you have to deal with. What I'm trying to describe here is that you can't say everything changes, that time's done. You have to say, at what rate is this specific thing changing at? What is the change gradient between state A and B? Let's have a look at that. So everything changes at its own pace. A database field name change or an export format, adding that to your app, well, there's different tasks that you have to do, different pieces of code, it will change. But how often will a new export format come in? Or how often will a database field name be required to change? Right? What's the likelihood of that happening? Compared to perhaps refreshing the stock, the data in the database. Well, the data is something that's going to change more frequently than the structure of the schema, right? That's going to change at a different rate. So we often locked into this kind of present state thinking, right? We're under engineering. Think of that dotted line, and we're under engineering, over engineering. We're often locked into some state in time on that line, and somebody says, oh, how difficult will it be to change? And we think about it and we say, well, a week, right? This is my estimate to change that to that. And we go, oh, we can't really do that for now, but I'll remember that, thank you. And a couple of months pass, and oh, remember that thing you were going to change? Well, let's go and change it now. And it takes you 4 weeks to do. And the reason, because the distance between A and B has changed, and so has the gradient. If you put some cardboard boxes out by the bins, and you leave them outside overnight because you don't have time to put them in the recycling for whatever reason, and you wake up in the morning, you go outside and you take care of it, nothing's happened. But if it rains overnight and the cardboard boxes are now soggy and breaking apart in a terrible way, your gradient, the change that you need to do from A to B, put the cardboard boxes into the recycling, that is of course now changed. So really we're looking at the change state between A and B, and that it's not as simple as that. When you're expected to make a change between A and B and you delay it, B shifts. It becomes C, whatever C is. The change that we need to make changes. What's very important to understand here is that change and complexity can refer to how we change something from one thing to another. But it's also to do with the state, the number, the value, the gradient. It's a very important thing. So change has a gradient. I mentioned the cardboard box outside. The point here is that if you delay, if you reactive, if you don't make an account for the future, if you don't look to the future, if you don't look to see the weather forecast, if you don't calculate the complexity that may happen should it have rained, should it rain, then you're creating a form of technical debt. And that technical debt, which is a slightly different metaphor, but very similar, is where I think our complicated world sits, where our software becomes difficult. Exponentially, the code is just getting more complicated anyway, but when we make decisions on a reactive way and delay and put off and put technical debt into the system, it has an effect. And most likely a larger effect than you have imagined. If you have not considered change rates, if you have not considered the change gradient and the delay, the delay and what it causes to the gradient of change and complexity, then you haven't thought it through. Then you haven't got a firm grasp on the complications. And most of us are probably making decisions thinking that we've got it right, that we've delayed it for a reason, and it was a good reason, and that delay is somehow justified. We probably don't have the numbers. We probably don't have the reality, the truth behind that. The honest truth is that we're most likely in some kind of cognitive bias. We're most likely skewing results. We're most likely thinking more positively about ourselves, our abilities and our actions. And it's most likely that in a network full on dynamic system that we have complications, introduce complications that are far greater than we could have imagined, but we settle with it and we just get on with it. And when a card comes, it comes up and somebody works on it and we think that we're moving forward. So let's just take this sort of idea that it's not one state A to B. So I'm calling this a phase transition. This is the language. I think this is traditional language, or maybe I haven't got that right, but if I'm going to alter a database field name, and I know I'm going to do it, this is the time, I've just figured this out, I've just gotten the message somehow, this is what I need to do. At that very point, the change rate is 0, and I can make a choice. I can make a choice. Is this 0? It has no effect. I don't need to do this now. Is it a high change rate? Is it going to change more often? Is it something that needs to change for a reason, and that reason is good, right? Is it a good reason? The change gradient is 0 because I've just realized that I need to make this change, and therefore the difficulty, we're going to have to start from 0. Because we probably have no calculation or working out what that change is going to entail. And it's probably not good enough to say, well, how many occurrences of the field name, let's count them. It's going to take me 3 seconds per, or I can do a find and replace. That's how long it's going to take me. It's probably not as easy as that. And in a field name change kind of scenario, you're probably close, but you're not going to be close should it involve 10 classes, a workflow, business rules, and some other things that need to be changed. In that scenario, you're going to be far less likely to make the right decision or understand exactly what's going to be changed until you're actually doing it. At the point that you understand that a field name must be changed and you're going to do it, you have a decision to do it now or later. And if you do it now, the change rate is 0. It is exactly whatever the difficulty is to change, whatever the complexity is in doing that change. That's what it is now. We call that 0. But if you delay and you leave it for the following week, following month, what other code has been checked in? What other things have been used that need that field name and so on? And therefore there's going to be a change to that state. And that, from 0, becomes its gradient. So, can you calculate this? Probably not. I'll give it a go. I'm going to think about it. Hopefully others will think about this. Can we calculate? It's really the change that needs to occur, but also the rate of change and the change gradient, with each passing week. Wouldn't it be great to have a tool that said, look, I wanted to do this change, click a button, show them what the change is, it does a calculation, it marks it as 0, and you say, right, now I'm not going to fuss with this, and next week you can click a button and it'll say, well, that change you wanted to do, well, it's 0.1 now, right? The difficulty has increased, and you can do it again the following month and it says, oh, it's 0.9. You go, why? What's happened? Well, you see, somebody's committed a few reports that use that field name, and there's a couple of additional functions that use that field name and so on. And so that complexity could be evaluated. And without understanding what is going to change and what has changed, we're not really empirical about anything that we're doing. It's one thing to say everything changes and I'm going to gear up my systems, but if you don't have to do that change, and if you're delaying things while doing this for later, and that has a change gradient that you're not even aware of or don't care about, you're just making your life difficulty without knowledge, with ignorance. So you can see here, I've got on this little thing, I tried to kind of illustrate, basically if you had to delay, you've got state B and a short term. You've got immediate, you've got a short term, medium term and long term, and I kind of equate those to quarters in a year, right? So immediate, I'm going to do it now, short is going to be next quarter, medium the quarter after that, and the long, is going to be 12 months away kind of thing. So how does that gradient increase? I don't know. I don't know what that number is. I don't think we're ever going to know, but hopefully. But this is closer, I should say, to the real thought that we need to put into what decisions we make. Whether we under-engineer or over-engineer, whether we should or shouldn't do something. So let's look at something that we can predict, something where, right, it's not like a field name. We're just going to count the occurrences of where it's changed, and it's pretty simple. But let's imagine somebody comes through. There's a request to add a new step into a workflow, and it's designed okay. You've got a composite design pattern. You've got some loop going on. You've got some database configuration to construct the nodes within that workflow and process. And you've got halts, and you've got continue, and you've got breaks, and you've got jumps, and you've got all these things in your workflow kind of process. And adding a new step's not too hard, but it does mean you have to go into the code and you've got to say, find that location, go somewhere and say, right, transition or whatever you're calling it, or add, step, configure the step, create some class derived from workflow item, whatever it might be, and boom, it's not bad, it's easy, I've changed it. They've asked for a particular rule, and it only applies to, maybe an office worker of some role within the application, so that was easy enough, right? Add a new step, change a rule, add a permission, and it's there. So the change rate 0.2 would suggest that during that year there is an occurrence of, 2 times. Somebody's going to come in and say, well, I'm going to do this, I'm going to ask you to add a new step twice for the year. And in that case, it might be pretty simple to do this manually, right? Your code is agile enough, right? It's modifiable enough. It is maintainable enough for you to go in, make these changes without much effort. Maybe you've got some tests to make sure you don't do something wrong. Maybe you have to write some new tests. And here you are, and it's fine, and it's twice a year. Now, what happens if it's 7 times a year or more? What happens if it is so obvious that you're going to need to add a step and so on, that you begin to have a thought that perhaps it should be customizable in some way? Now, that's a whole new ball game. That is not something that you take lightly. It's not something where you've got a workflow, you can add a step to it pretty easy in code in design time, or you've got a highly configurable, file or database configurable mechanism that can piece together workflow in a different order, and you can shuffle and change and add and remove, and it just works. That's a different ballgame, right? That is a higher complexity. That is more design work. That is something that you need to get more correct than something as basic as something you can edit and do in a sort of a white box sort of way, right? In a black box sort of way, configurable, there's more workload to do. Now, if you can predict, and this is really the point of this, if you can predict that it is in the very business, it's the type of audience that we're building this for, it's part of the application's sellability, it's part of what we need in the application. If you can identify that at the beginning and know that it should be customizable and do it up front, that is a far better way than leaving it in some kind of emergent, test-driven design, continuous, iterative process to get there. It is far better and less wasteful to go there and implement that, right? To get the dependency implemented, to choose it now, to build your own, get the bespoke system with the right requirements today. Even if you feel that, and this is the trade-off, even if you feel like it's not going to be used, we're not going to roll this out in version 1, it is probably best to over-engineer this part because it's fundamental to the application. And predicting that is often not as hard as we think. Because really, applications have a core. And if we think about that core, we will understand what that core requires in order to be more agile and more maintainable and so on. Okay. So I want to end it now. It's gone on a bit long, I think. But I'll leave you with just showing you a little bit more of the slides, and leave this for the next video. Thank you for watching.